Batch reactor overview. This video will contain some basic information on one of the most commonly used reactors for a variety of different products, and will explain when you would and would not use a batch reactor. Assumptions that are commonly made for a batch reactor is that it is contained in a closed system. Most often, batch reactors are used for liquids, and we also assume that the reactor is well mixed and therefore concentration and temperature do not vary throughout the tank. Cooling in a batch reactor is done using an external heating jacket. This controls the temperature of the reactants in the case of an exothermic reaction. Scale-ups for batch reactor is usually quite simple. For both isothermal and adiabatic systems, in which no heat is added or removed, the system scales up with volume because concentration over time does not change. The main difference in scale-up of a batch reactor is in terms of heat transfer. As you increase volume, your surface area does not increase as quickly, and therefore there is less room for heat transfer. If we start with a reactor with a diameter of 1, whose volume and surface area are also 1, when we increase the diameter by a factor of 10, our volume increases by a magnitude of 3, and the surface area only increases by a magnitude of 2. The mole balance of a batch reactor can be used to demonstrate why concentration is the only thing necessary for scale-up. Using a standard A to B system, we know that the total moles of species A per time is equal to the rate of reaction times the volume. Given a rate law, such as this second order one, we can then substitute into the original equation and get that dNA over dt is equal to negative Ka Ca squared times the volume. Noting that Na is equal to Ca times the volume, we can see that the volume terms cancel out. This leaves us with Ca over dt is equal to negative Ka Ca squared. This clearly demonstrates that volume does not play a role in the scale-up process of a batch reactor. So why would we ever want to use a batch reactor? In the case where you want a small-scale production, such as drugs or dyes, when you are implementing a new process or an untried reaction, when the material is of high value, when there is a long reaction time, when there's rapid fouling of the reactants or products, and when contamination and fermentation occurs easily. When would you not want to use a batch reactor? When there is poor mixing in the system, when there's impurities, when there's heat transfer in the system, longer startup times, or when the reactor materials contain catalytic properties.